Okay, they say there's positive integer solution to this equation over here. I want to point out there are no positive integer solutions to that equation over there. This is a linear Diophantine equation, and the GCF between 2 and 4 is 2, and 2 does not divide 3. So there are no positive integer solutions to this problem over here. So what I could say is the only appropriate answer here is this one over here. However, I do realize that some students may take a different approach to the problem and believe there's a correct answer that's actually listed over here. Let me erase this over here and tell you what some students would actually go through now. What are they going to go through? They're going to look at this and try to figure it out, all right? But again, the correct answer is just the correct answer. There's no other correct answer, by the way. So what they may do is they may look at 16 to the x and just see if they can simplify the problem. Well, 16 is what? 2 times 2, that's 4, 8, 16. So 2 to the 4, that's raised to the power x, so 2 to the 4x. And 256 to the y, well, that's going to be 2 to a power as well, but a little more complicated. 2 times 2 is 4, 8, 16, 32, 64, 128, 256. That's 2 to the 8th. And you can get 2 to the 8y. And then you can write this down, 16 to the x over 256 to the y would be 2 to the 4x over 2 to the 8y. And I would consider this to be very good if a student did this, by the way. You would get 2 to the 4x minus 8y. Looking a little more familiar, this is going to be 2 times 2x minus 4y. And by the way, 2x minus 4y is equal to 3. Unfortunately, there's no integer solutions that would produce that, by the way. So what do you have here? 2 times 3, which is 2 to the 6th power. Well, let's go through that. 2 times 2 is 4, 8, 16, 32, 64. So I realize some students might say 64 is the correct answer. It's not. Again, why is it not? Because there are no positive integer solutions to that particular equation, right? It has no integer solutions, by the way. All right, so I want to point out I do tell you where this is written up for you, but it is discussed repeatedly in class, by the way. And most of the equations, I shouldn't say most, I think every single equation we've given you has been a Diophantine equation. What does that mean? There's finger number solutions to the problem, and there's integers, all right? This particular example throws us for a loop, though. This test question here, I believe, was given on an SAT. And an SAT, I think some students in the room are familiar with it, but an SAT is a scholastic aptitude test, or at least what I know it to be. It's been around a long time, and it's certainly changed over the years. But it's a typical test that they give students in high school to see how well they know the material. And again, I consider this to be a really good question. However, I do understand why some students would choose this to be the correct answer when in fact it's not. Thank you so much for paying attention.